So these are the three rays: ray parallel to the principal axis, a ray passing through the optical center, and a ray directed towards the focus. These are the rays which we consider. Okay. In the case of concave lens, what are the rays you consider? Concave lens.
Concave lens. Same, those three rays. One is parallel to principal axis, another is incident plane, another is directed towards the optic center.
And this one is a concave lens, and this is optical center, and this is focus, and this is another focus. In this case, the left hand side object is there, and this will be second focal point, and this is a first focal point. If I consider one point source here, you said that one ray we will consider is parallel to principal axis. Okay. Second ray you said that directed towards the optical center.
Optic center.
And which is the third one?
Third one is passing through the focal point.
Passing through the focus. Okay. Suppose. Then what will happen to this ray? The ray parallel to the principal axis, what will happen to the ray?
It will appear to diverge from the focus.
So this ray will be going like this, okay, diverging like this, it will go like this, okay, I read. And the ray directed towards optical center, what will happen?
It will pass out undeviated.
It will pass through that point without deviation, okay. Okay. And what will happen to this ray?
This ray will, I don't know.
You don't know. Because that is not the ray you need. This ray passing through the focus is taken in the case of a convex lens. That already I have told you just now. In the case of concave lens, the ray not passing through the focus, we are taking the ray which is directed towards the focus. We will consider a ray which is directed towards the focus, towards this first focal point, not this one. Two rays are common in both the cases. What are the common rays? Ray parallel to the principal axis and passing through the optical center. Those two rays are common in both the cases. In both the cases means in the case of convex lens as well as the concave lens. But in the case of concave lens, the third ray is directed towards focus. In the case of convex lens, the third ray which we consider is passing through the focus. Understand that difference. This ray, the one which is directed towards focus, what will happen to that ray? That ray will become parallel to the principal axis. And if I am producing it backward, no, I will get the image here. Here I will get the image. Okay, this one. This is source, point source. This point will be the image. I have taken a point source only. I did not take an extended source. So you just remember these are the three rays which we consider when we make the ray diagrams of a concave lens. Here, see, this is our concave lens. And the object is at infinity. If object is at infinity, what is the speciality? Light rays coming from one point will be parallel to the principal axis. The rays coming from infinity will be parallel to the principal axis. So how will they go? If this is the second focal point, and the same distance here you will have first focal point. Okay. Here these rays appear to diverge from this, and you will say the image will be formed at focus. That means if your eye is here, if this is your eye, when you look from there, you will see the image here. This image you can see only, you cannot produce this image on a screen. So this image is a virtual image. This image is virtual image. So what is the nature of this image? Nature of image is a virtual. And virtual images are erect. So you write virtual and erect. So I have given the condition when the object is at infinity. When the object is at infinity, image formed will be virtual and erect. And what about the position of image? Position of image is at focus. Then we will write the size of image. What you can say about the size of image? Image is a point size. No need of showing the eye, just to show the rays, that is enough. Done.
Yes, sir.
So position of image I have written, that is at focus. Nature is a virtual and direct. Size of image is a point size array. Point size means highly diminished. Okay. This together, nature and the size together is called the characteristics of image. This together is called the characteristics of image. So if characteristics of image is asked, you must write nature as well as the size. Please remember, position of image is not the part of characteristics. Okay. And then another case you can imagine when the object is at a far distance. When the object is at a far distance, our object is at a far distance, not at infinity. You can think about a tree. A tree is at a far distance. When the object is at a far distance, light rays coming from one point will be parallel to each other but not parallel to the principal axis. So which are the rays which we consider? One ray, there is no doubt, we will take a ray which is directed towards the optical center.
Optical center.
Okay, that ray I can consider. Which is the second ray I can take in this case?
A ray directed towards F1.
The ray directed towards the F1. Okay, parallel to this, a ray directed towards F1. Okay. What will happen to the ray which is directed towards optical center? As you know, that ray goes without deviation. Okay. So this is incident ray. You show the arrow mark. This is the refracted ray. Again arrow mark. Whenever you show incident ray and refracted ray, don't forget to put arrow mark. What will happen to this ray? Already we have seen that ray will be parallel to the principal axis. So that ray will go like this. Here I have got two rays. One is this one, another one is this. And these rays will go diverging like this. So these rays will not meet. These rays will not meet even at infinity. Our assumption is like this: parallel rays will meet at infinity, but these rays will not meet even at infinity. So in that case, where will be the image formed? If your eye is here, when these light rays reaching your eyes, you will feel that these light rays are coming from one point here. For that, what we must do? We must produce it backward. We will produce this ray backward. Okay. Then it will touch at one point here. Okay. Here you will get the image. So since this is an external object, our image will be like this. Image will be formed in the focal plane like this. In this case, position of image. Position of image is at focus. Then characteristics.
Nature and size.
Okay. Nature, what is the nature? Image is virtual.
Virtual and direct.
Virtual and direct. And size, we will say highly diminished. Highly diminished. Last case image was a point, but this case image will not be a point, image will have some size. It will not be a point. If the object is really at infinity, our image will be point. Okay, here I am not writing point size. Now only one more case is there for when the object is anywhere in front of the lens. Anywhere in front of the lens. Other than infinity. Infinity case we already discussed. So anywhere in front of the lens other than infinity. Can you see this what I am writing? Yes.
Yes, sir.
You can keep the object anywhere you want. Wherever you keep the object, characteristics of image formed will be the same. Even if you keep it here between optical center and the focus, or between f2 and 2f2, or beyond 2f2, wherever you keep, these characteristics of image will be same. So what are the rays you are planning to take?
First is parallel to principal axis.
Okay. What will happen to this ray?
It will diverge.
How? Like this.
Yes.
Am I correct?
Yes. It would appear to diverge from focus.
Okay, so I am wrong. this time. Okay, this way. Okay, then
In second ray, passing through F1.
passing through.
F1.
No, it cannot pass through F1. How will it pass through F1? It is not
Sorry, directed towards F1.
directed towards F1. Okay, you can take that ray if you want. Okay. Then what will happen to this ray? This ray becomes
Parallel to principal axis.
parallel to principal axis. Because this ray was directed towards F1. This ray is directed towards F1. So it will be parallel to the principal axis. So where will be the image formed? Between this optical center and the focus.
Yes.
Draw the image also. Virtual images will be shown with the broken line. Okay. Good.
Yes.
Will you show me the image?
Yes, sir.
How is that?
It is virtual.
Virtual image because the fractal rays are diverging. They will not meet. Image will be virtual. I want to see that whether you got the correct position of image. So I just ask you to show me the image. Okay. Hold it like that for some time. Let me check one thing. You are wrong. Listen to me. So you thought that the image will be formed here and you made the image here.
Yes, sir.
You made the image here, right?
Yes.
That is wrong. The reason is that you must produce this refracted ray backwards now. This refracted ray must be produced backwards, right? Then it will touch here. So virtual image will be formed here only, not here. The refracted ray is produced backwards. This is the first refracted ray. That ray is produced backward here, and second refracted ray is produced backward. Then image will be formed here. Isn't it?
Yes.
And one more thing. You suggested this ray which is directed towards F1. In fact, if you are suggesting this ray which is passing through optical center, your work was easy. If you have taken this ray now, which is directed towards optical center, then without any difficulty you would get the image at the same position. Here itself you would have got this image. Here itself this point will be same only. Here itself you would have got the image. Anyway, you suggested that way, it is okay, no problem. But remember, the refracted rays must be produced backward. In this case, if you have suggested this ray which is directed towards optical center, if that ray is produced backwards, means that same thing only. So image will be formed there. Did you understand?
Yes, sir.
To check whether you understood or not, I will give one question for you and I will stop this class. An object is kept. Object means an extended object, okay, not a point source, point object, an extended object. An object is kept at the focus of a concave lens.
Concave lens.
Draw a diagram to show the image formation.
Draw the diagram to show.
Draw a diagram to show image formation. Draw a diagram to show image formation.
Concave lens.
As per my question, this is concave lens, focus f2, f1, and I said object is kept at here at focus. Your work is to copy and complete the diagram to show the image formation. Do that fast. Hello.
Yes, sir, I'm drawing.
Only 2 mark question. Don't take more than 2 minutes.
It's almost done. Sir, again, will the image be between optical center and focus?
You draw.
I'm getting that.
You draw wherever it comes. Doesn't matter. Let me see.
Okay, I'm done. I'm showing.
This time you have taken the ray directed towards focus. Okay, that ray was parallel. You produced it backward. Another ray you took. Okay, correct only. What you have drawn is correct. One ray you have taken like this. This is not a broken line. The ray is there. This is not a broken line. Another ray you took directed towards focus. Okay, that ray till here it is. Then it is like this. Okay, you are right. I think. Excuse me. Yes, you are right. This will be parallel. This will be parallel. Okay, and then you have to produce it backward. So image will be there between focus and optical center. Image will be virtual and direct. Okay.